Hey there, Cloud. I wanted to go through this problem with you on my iPad software, so I hope you enjoy it. We'll just get right into it real quick. That's Messenger to help me figure out how to do this. Alright, so this is your problem, number 5. Okay, still I'm pretty new to using this stuff, so let me know how well it works, please. All right, so first let's start off reading the problem. It says the quadrilateral at the right is a kite. Quadrilaterals have 4 sides. And if you look, this quadrilateral does have 4 sides. We can go through all 4 sides here. 1, 2, 3, and 4. All 4 sides, and that is a kite. Now, what we want to do is complete mathematical statements about the kite using the given symbols. We want to prove each statement algebraically. So, in other words, we want to do a proof. Now, these proofs aren't going to be too complicated. I hope you don't get scared. Proofs oftentimes are not very complicated, but they feel that way to new proof people. Okay, so because we're working on number 5 here, BDAC. So we want to look at those two lines and see the relationship between those two lines. So if I look, first I'm going to find BD. BD is right here. Take a look at that line and compare it to this line right here. How are those two lines related? Well, this problem gives us a little bit of a guide as to how the two ones are related. If you look right here, there are several different options that we can choose. Okay, and we'll go through these options one at a time. Are these two lines congruent? Definitely not. They're not the same size. They're not the same. Well, they are lines. They're kind of the same shape, but they're not the same size. Are they perpendicular? Well, they look kind of perpendicular. That one might be true. Are they parallel? Parallel means they're going in the same direction. They're definitely not going in the same direction. They're not parallel. Now this one says, is BD less than AC? Is BD less than AC? Well, it looks like BD could be less than AC. So that one might work as well. And the last two, is BD bigger than AC? Definitely not, so that one's not going to work. And is BD equal to AC? That one's not going to work either. So we either have perpendicular or less than. Now, because these are shapes, shapes aren't numbers. Numbers can be less than or greater than, but shapes don't really have that relationship. So even though BD is kind of smaller than AC, we can't say that it's less than AC, because they're shapes. Okay? All right, so we want to prove that they're perpendicular, that BD is perpendicular to AC. So in order to do that, we need to remember what perpendicular lines, how perpendicular lines are related. So thinking about perpendicular lines, hopefully you remember the thing we repeated so many times in the last module, is that perpendicular lines have opposite reciprocal slopes. So perpendicular lines have opposite reciprocal slopes. What this means is that if we have slopes that are opposite reciprocals, we're going to have some perpendicular lines. Well, let's go ahead and see if their slopes are opposite reciprocals. In order to do that, we need to get the slopes for each one. So the first one we'll do is, let's check out the slope for BD. What is the slope for BD? So we come over here, and we want to draw a slope triangle to find the slope. Anytime you want to find a slope and you got a graph, slope triangle's easiest way to do it. So if you look across the bottom, it goes across 4 or over 4, and it goes up 2. So the slope for BD is equal to 2 over 4. That's the rise over the run. 2 over 4. Now, that 2 over 4 can simplify down to 1 over 2 because both are divisible by 2. So we can rewrite this as 1/2. The slope of BD is 1/2. Now let's take a look at the slope of AC. Since they should have opposite reciprocal slopes, that's what we're going to try and see right now. So again, we need to do the same thing, get the slope of AC. So if I want to get the slope of AC, easiest thing to do is make a slope triangle, just like this. Okay, I got my nice slope triangle right there. And with my slope triangle, I'm going to go ahead and see, it goes down 1, 2, 3, 4, 5, 6. It goes down 6. Because we're going down, we're going to include that negative there. Negative means to go down on our grid. And then it also goes over 3. So if we look at this, our slope is going to be negative 6 over 3. Hey, wait, 6 and 3, they're both divisible by the same number. Both of them are divisible by 3. So 6 divided by 3 is 2. 3 divided by 3 is 1. And so this actually simplifies down to negative 2 over 1. Now take a minute and consider the slope of this line and the slope of this line. How are those two numbers related? Well, one is 1/2, and I'm going to write it over on the side just so we can see it a little clearer. We got 1/2 versus negative 2 over 1. Now, if you look at those, they're flipped, and they are opposites. Now, opposites are always numbers that one's positive, the other's negative. So they're opposite numbers, but they're also flipped, because one is 1/2 and the other is 2 over 1. Because of that, that flipped is another way that we describe reciprocals. Okay, so now we know that they are opposites and reciprocals. Since the slopes are opposite reciprocals, the lines are parallel, or sorry, perpendicular. Let me get a final conclusion we can write here. Okay, these slopes are opposite. Sorry, just a second. Whoa. Let me fix one more thing real quick. There we go. Opposite reciprocals. Because the slopes are opposite reciprocals, BD is perpendicular to AC. And that's our conclusion. So we had a statement right here. Just to summarize everything we did, we have a statement right here. And then here are reasons. This part is our reasons. Okay? We have our statement, we have our reasons, and then we have the conclusion on the bottom here. Okay? Got your statement, your reasons, and your conclusion. I hope this helped out. Let me know how well it works, because I definitely want to do this a little better with all this remote learning. Thanks. Bye.